Good day and welcome back to our third installment on limit laws. In the previous two videos, we were able to introduce the limit laws and work our way through several examples and build up to this substitution property. So in this video, what I'd like to do is begin by reminding ourselves of the substitution property and then immediately look at a few examples where we are unable to apply the substitution property at least directly to start the problem. So recall the substitution property is kind of an ideal scenario, and you can almost think of this as being like an 11th limit law. It tells us that if the function we are taking a limit of is a polynomial or a rational function, and just to make sure that we're all on the same page, remember a rational function is something like a polynomial over a polynomial. So for example, the function we are going to encounter in a moment, this is a rational function. It is the polynomial x squared plus 4x plus 3 divided by another polynomial x plus 3. So if f is a polynomial or rational function and a is in the domain of f, that is, we can plug it in and not worry about dividing by 0, then the limit as x approaches a of f of x is almost the easiest possible example we can ever evaluate. We simply substitute a into our function, and we get back f of a. But recall, as I mentioned, each and every time you use the substitution property, you do have to justify that for me by putting an SP over the equal sign. That indicates that you've thought about the fact that we can apply the substitution property, and you're not just doing this randomly. So now on to a few of the more interesting examples. That would be when we cannot directly apply the substitution property. So let's begin with the limit as x approaches minus 3 of x squared plus 4x plus 3 over x plus 3. So it is a rational function, but note there's an issue. Minus 3 is not in the domain of this function. It's the only value of x which causes us to divide by 0. So let me just note to the side here, we cannot use the substitution property. The reason being is minus 3 plus 3 equals 0. And we do not ever want to divide by 0, i.e. minus 3 is not in the domain of that rational function. And what that indicates we need to do is some type of algebraic manipulation. And in this case, there's really only one algebraic manipulation that jumps out at me. This quadratic that we see in the top is something that you can factor. So take a moment, pause the video, and factor that quadratic. And assuming that you've done so, if not, pause the video and factor it, what you'll find is that quadratic factors as x plus 3, x plus 1. And note that x plus 3 in the top cancels x plus 3 in the bottom. So this becomes the limit as x approaches minus 3 of the function x plus 1. And what I would like to note is that if you look at this function x plus 1, you could certainly evaluate this limit quickly using our limit laws, but x plus 1 is a polynomial, and polynomials are defined everywhere. So this is a scenario where we can use that substitution property. And note, because I'm using the substitution property, I'm justifying it with that SP. So this becomes minus 3 plus 1, which is minus 2. And once again, which I will continue to mention here, is make sure that you are using proper mathematical notation. Equal signs at each step, limits at each step until you have evaluated it, and line things up vertically. If you neglect to do any of those things, you will probably be disappointed to see some type of point deduction and maybe slightly annoyed with the notes that you continue to get from me on your assignments. So let's look at another example. Moving on to our next example, this is a very common example. What we would like to do is evaluate the limit as x approaches 0 of the given function. Now, intuitively, what we want to think about is, can I just simply plug in 0? And in this case, you certainly can, in the sense of getting back a number. The function is defined at 0, but the problem is, this is not a rational function or polynomial because of the square root, which means we cannot use the substitution property. But don't worry, what we can do in this case is just directly apply our limit laws. And I would almost explain this as just kind of limit lawing this thing to death. We have the fifth limit law, which tells us we can take the limit of the top, divide it by the limit of the bottom. And then we're going to work through this just slowly and methodically. Now, the limit in the top is a limit of a constant, which is just that constant, so 1. And in the bottom, we can break that limit of the sum up into the sum of the limits. That would be the square root of x plus 4 plus the limit as x approaches 0 of 1. Note the second limit in the bottom is the limit of a constant, which is that constant. And the first limit, we still can't use the substitution property because it's a square root. But our final limit law tells us we can plug a limit or push a limit inside a square root function. So this would become the square root of the limit as x approaches 0 of x plus 4. And now, this remaining limit we have is a limit of a polynomial. So if you want to, you don't have to, you can continue with the limit laws. But because that is a polynomial, you are justified to use the substitution property. So this would be 1 over, and we just substitute in 0. And 1 over the square root of 4 plus 1 is 1 over 2 plus 1, which is 1/3. And if we were asked to evaluate a limit like this, I know it seems like a lot of work to show these steps, but it's really not. You know, it's only arguably 4 or 5 steps here. Now, I am perfectly fine with you jumping a bit in this first step. It would also be perfectly all right if you were to jump to the limit as x approaches 0 of 1 in the top and then immediately break that limit up over the sum in the bottom. But besides making that jump, I would then need to see every other step along the way to fully justify and explain your work. So that finishes up the examples we're going to investigate in this video, but we'll look at 2 more common examples of limits in the upcoming video. So stay tuned and take care.